here is a discussion of linear independence and why it's relevant to decide initial conditions. This goes with our discussion of section 3.1. So let's think about initial conditions. So time is absent in this picture. I'm looking at the initial value for the solution x at time t0 and the initial value for the derivative of the solution x prime at time t0. And I'm considering combinations of those two. So there's 2 dimensions worth of initial conditions, and I'm going to think of them in terms of vectors. So here is x1 at t0 and x1 prime at t0. That gives me a vector u. And here's x2 at t0 and x2 prime at t0, the vertical coordinate. And that gives me a vector corresponding to the initial conditions satisfied by x2. And so we're now thinking about some other initial condition. This blue point is some combination of x at time t0 and x prime at time t0. And if u and v are linearly independent, they're not along the same line, then any point in R2 can be reached by traveling some distance along u and some distance along v. So if u and v are linearly independent, then they span R2, which means that any initial condition can be reached by a linear combination of x1 and x2. Now, what does that mean? If we are looking at the homogeneous equation, then we know that the left-hand side of the equation is linear, so any linear combination of x1 and x2 provides a solution to the homogeneous equation, because on the right we get a times 0 plus b times 0, which is 0. And so we can get a solution to the homogeneous equation from a linear combination of x1 and x2, and we can match any initial condition. And since the homogeneous equation is always going to have solutions, because the right-hand side is continuous, and so we're guaranteed a unique solution, that means that we have found the unique solution to the initial condition by combining x1 and x2. If the equation has a non-zero right-hand side, if f of t is not 0, it's still true that we can find the general solution to the homogeneous equation and add it to a particular solution. And so again, that means that we can find all solutions where they exist. If f of t is continuous in only a particular interval, then solutions are only guaranteed to exist and be unique in that interval. And so what we just said applies only to that interval where the right-hand side is continuous. Otherwise, we don't know if solutions exist and are unique.